A ball with diameter 4 inches starts at point A to roll along the track shown. The track is comprised of three semicircular arcs whose radii are R1 is 100 inches, R2 is 60 inches, and R3 is 80 inches, respectively. The ball always remains in contact with the track and does not slip. What is the distance the center of the ball travels over the course from A to B? Okay, so the center of the ball. Well, I guess probably it's first we want to find the let's think about the center of the ball. How is that different from anything else? Because I think when it says the center of the ball, it's obvious then that it wouldn't be telling us that the diameter, like the ball's diameter, is obviously relevant. So maybe thinking about the length of these arcs. So to find the length of these arcs, it's going to be 2 pi r over 2. So for this first one, I guess circumference 1 is going to be, it's really just going to be pi times r then. Yeah, circumference 1 is going to be 100 pi. $80 pi. The ball always remains in contact with the track. Okay. I mean, I don't know if it's helpful then to calculate the circumference of the ball. The ball's circumference is 2 pi r. Or just pi times the diameter, which is 4 pi. I mean, is it how many times 4 pi goes into 100 pi? Like, I mean, imagining if this were just 4 pi, like, cut it off here. How far is the center of the ball traveling if this is just 4 pi? Yeah, just think about that for a second. If it's just straight, center of the ball, if this whole thing, this length is 4 pi, how far is the center of the ball traveling? So it's going to do one rotation around. This ball rolled. It's hard because I want to say that the center of the ball traveled, like it goes from here to here. Didn't it just go 4 pi? But I don't think so. I mean, my thinking here would just be 100 pi plus 60 pi plus 80 pi, but I don't think that's it. I mean, where is it here? How many rotations is the ball? Yeah, maybe it's a question of how many rotations is the ball doing. I mean, is it different if the ball had started such that, like, the bottom, like, Is the ball already, I mean, the center of the ball is there, but half the ball is already going here. I mean, does this, if we think about this like 4 pi, has it already, hmm. Yeah, I guess how many rotations does the ball make here? 100 pi. 100 pi divided by 4 pi is 25. I mean, so shouldn't it just be if it's making, I really just think there's something about the ball's diameter. It's something about the center of the ball. It's not just the arc length. As far as the center of the ball traveling. I mean, actually, technically, well, the center of the ball is doing something more like this. That's the center of the ball. Here, maybe this is it. The center of the ball's path is like this. Oh, so yeah. The arc that we're concerned with, the arc that this is making, this is interesting. The arc that is making has a radius that is 2 less than that. So instead of, let's just call it R1 prime, I guess. R1 prime, the radius of R1 prime, this radius is actually 98. And R2 prime is going to be 2 more than this. So it's going to be 62. And R3 prime is, again, it's a slightly smaller arc radius that is yeah, it's 2 less than 80, so 78. So therefore, the new semicircles are going to be, so C1 prime is 98 pi, C2 prime 62 pi, C3 pi is 78 pi. The sum of all these, these are the arcs we're concerned with. That's where the center of the circle comes in. These are the arcs we're concerned with, not what we were, not what I was looking at here. So the distance to the center of the ball travels with the course from A to B is this sum. So summing this together, 98 pi plus 62 pi is, that's just 160 pi plus 78 pi is 238 pi. So I would say answer is choice A. Choice A is correct.